All right, let's start. You are more than welcome here in Turku.ai event here in ATR office. My name is Teemu Tasanto and I'm CEO of ATR and I'm hosting this event together with Jani Anttonen, who is here. And if you in this evening have anything to ask or wanna help or something, just contact me or Jani, we will do it. Today we have three great speeches here. But before that, I want to say something about our facilities and about ATR. So, as you want already, there's snacks and drinks there. Please, free to take any you want there. Restrooms are behind the corner there. And of course, the presentation will be here. And then, as you can see, the presentation will be recorded. So, the track will be available after this meeting. And if you want to take pictures for your own purpose or to social media, you are free to take it here in presentation area here in our office. Katja will take some photos also for marketing purposes. So if you don't want to be in LinkedIn or in internet to see your photo, please say it to Katja so then she can take it. That kind of pictures where you are not there. All right. Shortly about ATR. We are a software company. And as you can see, we are located here in Turku, Kupittaa. There are 60 of us. We are mostly here. There are some people in other cities in Finland, like Tampere and Kemi, and we have one person working full-time in Denmark, but otherwise we are here. And what we do software development for big companies here in Finland, and we also do product business internationally. So there are some software what our researchers are selling all over the world. We have been already here 24 years, so we have been doing software business already this time. At the moment, we are doing about 5 million revenue, and there are a bit under 60 of us. And what we do with the big customers, here I mentioned some of our public references. For example, in neighborhood, there are Lowell there in the next building. Turku city is located next to building. We can see even Meyer Turku there. So we have great customers here in Finland, in Turku and in Finland in general. For example, Murata, who is world third biggest electric component manufacturer in the world, and also you all know Kone and Metso and so on. So we are having great customers here in Finland. Our vision is that we want that people love us and our software all over the world, and our work is based on this kind of values where we work together with this warmly flexible way and make an open and fair business. And during last 15 years, we have been formally asking from our customers that what they think about us. And here's the result of all of that 15 years. So normally customers are quite satisfied on our work, and that's in key strategy of our business. All is based that the customers are satisfied and they want to work with us. That's the way how we can work with the big companies like Kone and Murata and Meyer Turku and so on. As I mentioned, there's also international business. Resellers are selling our custom tools product in North America, in Europe, in Australia, and in Asia. And in Finland, when we are doing business with big companies, this is what we do. We do software development, we do integrations, so we make data flow automatically between systems, and we do artificial intelligence. We started to do machine learning solutions to our customers 5 years ago, and Ida-Liisa is talking about machine learning and large language model solutions today. And naturally, we are also doing large language model based solutions today for our customers. Okay, that was shortly my part. Have a pleasant AI evening here, and as I mentioned, you are really welcome here. Thank you.
My name is Jani Anttonen, and I'm with Vätsky ry, which is Varsinais-Suomen Tietojenkäsittely-yhdistys, which means roughly the Finland proper's ICT yhdistys organization. And I've been with them since the year started, and my job there is to host these Turku.ai events together with our great partners and sponsors. And yeah, so there's some random info, but the main point is Vätsky and Turku.ai, and Vätsky has been gathering this new strategy. We are trying to connect people, companies, meetups, etc. Be this focus point between all different kinds of organizations here in Turku and Finland proper, mainly in Turku. Maybe we should do something in Salo as well. But yeah, then Turku.ai meetups this year and going forward once per quarter. And the goal is to present this opportunity to gather around AI and mingle and get together, get to know the companies and professionals and researchers and students who are interested in AI, and hear about timely presentations. And yeah, please join the upcoming meetups after this one. And to do that, you can also apply as a presenter and apply as a sponsor for these events, and sign up for Vätsky News if you want to learn more about us and what we do. But yeah, I'll be posting these links to the AI event page later on, so you can all apply for presenting later. But let's hear about Ida-Liisa Parlin's thoughts of AI first.
Okay, yeah, hi. Nice to see so many of you here. What I'm going to talk about is the balancing act, as I've decided to call it, or when to implement large language models and when to stick with the more traditional machine learning solutions. And first, a bit about me. My name is Ida-Liisa Parlin, and I'm an AI specialist and project manager here at ATR Soft. I have a master's degree in digital linguistics or natural language processing. I got that last year from the University of Turku. And I've been here at ATR Soft since November 2022, so a bit over a year and a half now. And my background is actually in journalism and PR, so I changed careers. And yeah, I started here November 2022. That's the same month that ChatGPT came out. So while my studies were focused on like the more traditional machine learning, then GPTs and other large language models have been widely on my table for this past year and a half. And the thing I've noticed as these cases have come across is I've often found myself thinking of this quote. So if all you have is a hammer, everything looks like a nail, and everyone is basically trying to solve these issues with a large language model right now, but the way I see it is more like we have problems. Some of them are nails, some are screws, some are from other types of similar looking things. Background not in construction. But we don't have is a hammer. What we have is this, like a pile driver, which you can use to get those things in the ground, but it might be a bit too heavy of a tool at some cases. But before we go any further, I'd like to establish some ground rules, so to speak. So what we're focusing on is natural language processing, or issues where the data is in textual form. That's, well, where my expertise lies, and also you wouldn't really use a large language model to do time series analysis for something where the data is like purely just numerical, because that's not where they excel. So natural language processing and text data. We're also not going to go too deep in the technical nitty-gritty. So, for example, I won't be talking about the different architectures that have all these different models have, or what are the algorithms between the traditional machine learning solutions. So we're more going to focus on kind of the principles of things and the concepts themselves. And then regarding large language models, I'm going to treat them kind of as a whole. There are a lot of different models. They're different sizes, different licenses. Some you can use for commercial purposes, some not. But I'm going to, again, we're looking at the concept more than different models per se. But now I've said the words machine learning and large language models quite a few times, so it's about time we define them. So large language models, meaning models like OpenAI's GPT models, or the other ones like Llama, Bloom, Falcon. There are lots of those popping up all the time now. These big models trained on vast amounts of data that are usually generative, or if we kind of overly simplify, what they do is that they predict the next word that's going to come up in a sequence. Of course, what goes underneath the hood is a bit more complicated, but that's like the basic idea of what they do. They often have billions of different parameters, and they require quite significant computational resources, and they're also basically like black boxes. So it's really hard to know why they predicted the next word to be what they did, but that's how they work. And then what I mean when I talk about traditional machine learning, we have this logistic regression, naive-based support vector machines, neural networks, basically algorithms that you can train on a specific data set and to predict predictive modeling and data analysis. And in the context of natural language processing, these often need you to turn the raw text into numerical representations, whereas for some language models you can often, there is embedding going on and turning text into vectors, but you can feed more easily just language in itself. But yeah, these are often more interpretable. They're not as black boxes, or at least some of them, and they don't require quite as much power as the large language models. So these are often things you can run on your laptop. And then something that I'm maybe some now consider to be something in between these is the BERT and BERT-based model. So BERT is Google's kind of one of the first large language models that came out in 2017, 2018, which is, a large language model. It's pre-trained on the really large corpus, and it can be fine-tuned for specific tasks. But for example, the large version of the original BERT has 340 million parameters compared to the billions that the modern large language models have. So it's kind of not in the same really area anymore. So for the purpose of this talk, we're going to consider BERT and BERT-based models to be more in the traditional side. I think it shows you how rapid this development is, that this technologies that were cutting edge and state of the art just not too long ago, we're kind of already considering them traditional. But what I think is that you can do pretty much any natural language and processing task with a large language model, but maybe you always shouldn't. There then, of course, are cases with what you can do with large language models that you can't really do with traditional machine learning. Like, for example, this text generation and modern chatbots, you wouldn't do that with a logistic regression model. That's basically just an simple algorithm. But then again, with these large language models, we can do pretty much anything. So when we think of these kind of good old-fashioned natural language processing tasks like named entity recognition, which is basically picking out names of people and organizations and places, and these kind of things out of text, you can do this with an LLM, just like you can do text classification or sentiment analysis with a large language model. But when you should use a large language model, when the traditional ways, that is the question. And the way that I thought that we could approach it is we have this kind of hypothetical use case. So let's think that we have scraped emails and product reviews and company reviews and maybe mentions from different social media with maybe our company's hashtag. And now we've ended up with this like large data set of different texts. And we'd want to get these texts into different categories of some sort. Then we'd want to know which specific products and organizations, maybe people like customer representatives were mentioned. And then we'd want to know if they were positive, negative, or neutral towards our company. These are basically the basic good old-fashioned NLP things. So we want to do text classification, then named entity recognition, make sure we don't get just our company, but also maybe someone was comparing us to someone, so we want to catch those as well. And then we want to do sentiment analysis last. So the good old-fashioned things. And the way that we could do this with a large language model is through prompt engineering. And I came up with this kind of prompt. So we tell the large language models what we want to do. We want it to take the text and do, well, basically all the things that I just said. We can say that for the categorization, we want to use a set of categories, but I was too lazy to come up with any, so there's just categories. And then we could say we want the answer in JSON format so that we can actually do something with it and feed it into the next system without having to manually or by hand extract the answers that it gives us. And then finally, we have a magical sentence of let's think step by step, which for some reason makes many of these large language models actually perform better at tasks like this. We don't really know why, but it works. And we can test this out just in the ChatGPT, in the free version. It gives you the option of giving like instructions to the model on how you want it to act. So I just copied and pasted this prompt that I made. Again, too lazy to come up with categories. We'll see how that affects us. And then I found a review of OpenAI from Trustpilot, which says that, well, there's products mentioned, ChatGPT, Apple. They say it's great, they love it, but then they have some issues with it. And then I'm just copying this, pasting it into my kind of tuned version of ChatGPT. And what I get out is the JSON format of the information, just like I asked. So there's no, sure, here's the info you asked, but it's just what we want. And it even came up with a category for us when we were too lazy to, or well, I was, to come up with any. So it categorized this as user feedback. So yeah, really simple. And one might think that this is the perfect solution. Why wouldn't you do anything else? It's really fast to get it up and running. There's no long pipeline that you have set up. If you use like one of these models that you can just use through an API call, then it doesn't take much time at all to build this whole thing. But then there are some downsides, and costs is the first that comes to mind. If we are using a model like this, like OpenAI models from or through OpenAI or Azure OpenAI, that you're basically paying for every request and by the tokens. So you want to do some calculating on if that's something that you're willing to pay. And if then if you're using an open source model, then you need to, well, put it somewhere. It's maybe not going to fit on your laptop. So cloud costs again on computational costs from that. And then there's the question of accuracy. How are you going to know how good it was at actually, did it pick the right things out? Did you get everything? How good is the classification? You're going to be in the dark. You're not going to have like factual information about that right off the box. And then, of course, data governance issues. So, for example, you might be working with an organization or with data that's not okay to put in the cloud, or that's not okay with the data retention policies if you're using OpenAI's model. So that's something you have to take into account. If you fine-tune a large language model of your own, is that going to be okay with your data? Is that going to be okay with your customers' data? So there's a lot of like boxes that you have to tick before you can be sure that you can kind of go with this route. And like I said earlier, these are black boxes. So you're not going to know why it, for example, said that a review is negative, neutral, or positive. And if that's not something, if you're working with data, you don't really mind not knowing why it did what it did, then that's fine. But model interpretability is something I'd like to spend a minute on. So if you don't know why the model is making the choices that it does, how can you know you're focusing on the right things? For example, in this case, marketing might want to really know what are the aspects of the products that are praised or criticized. What are the things that make a review positive or negative? What are the things they mentioned? And if you're using an interpretable model, you can get these features out, like these are the things that made this review positive, or these are the things that made it negative. And then you might ask, well, if I analyze the reviews after I've classified them, then if you did it this way, how can you be sure that you're not missing any important data? If you had 1 million examples, for example, you're not going to go through them by hand checking if the AI was correct, because then you might just as well do it by hand, the labeling itself. And because it is difficult to know if the model is focusing on the right things. One example that I had during my university years is they were training a model on image detection, trying to figure out if an image was of a dog or a wolf. And they made a model that was pretty good, pretty accurate. They got good results. And then they did these model explainability techniques, so trying to figure out what makes a wolf. How is it making this distinction? And what it turned out that they had made was a snow detector, because the wolves were photographed out in snow and the dogs inside. So the model didn't have any idea of wolfness. It was just checking the background for snow. So with an interpretable model, you can know the exact language that led to the classification. So you can make it easier to know, you can justify your decisions if you know that the model is focusing on the right things. And then again, also, if you notice that it's picking up on the wrong things, you can tweak your model and make sure that it is focusing on the right things. But yeah, that's it for the large language model side. If we were to do the same tasks that I described earlier with the traditional approach, we'd have models for each step. We could have a pipeline that feeds the text first into a classifier, then a named entity recognition tagger, and then a sentiment analyzer. And here we could use different tags for different tasks, depending on what works best. The classification could even be a rule-based system. It doesn't necessarily have to be that kind of cutting-edge AI at all, if that's what we could be fine with. Then we could use a BERT-based model for the named entity recognition, and then even something as simple as a support vector machine for the sentiment analysis, and then get out the features, what made a review positive or negative. And yeah, interpretability is the big key here. We can get insights on why the model does what it does. We also have more control over each step. We can fine-tune things. We can really get into the nitty-gritties of each model and make sure that how they work. And of course, the required resources are much lower for the computational part. We don't need the big GPUs for this necessarily. But it is a lot more hands-on work. So it's not as simple as one API call. And what also creates a lot of work is that we are going to need labeled data for training the models. So someone has to be making at least some batch of the reviews and marking them by hand, for example, if they're positive or negative. And if we could have like 3 models. If we want 1,000 examples for each, then that's 1,000 times clicking through things. And that's assuming that one model for each step is good enough. For example, if we find we had earlier scraped emails and reviews from different sites and social media texts, maybe one model is not good at generalizing for the sentiment analysis for all of these. We might need a separate one for tweets and a separate one for the other kind of text. So we could end up doing a lot more hands-on work here. So then here, just to kind of compare and go through what we went again. And then, of course, for both of these, there's the considerations of retraining, model upkeep, how we're going to do that, how much resources are we going to need over time. And yeah, some other things that could also, that we might need to take into account is if the data is multilingual, for example, then a large language model might be better at figuring out or generalizing to different languages. But then again, if we get into the ethics and morals kind of mindset, then the LLMs, like I said, they're a black box and they can have all these different biases that we don't really know about. So that might affect on why it's making certain decisions. And of course, when we think about the environmental factors, then the large language models are notoriously not very green. So that might be something that we also want to take into account. But then if we're really at an impasse, we don't know which one to choose, we could also choose both, basically. So we could, for example, use large language models to label the data, reducing the resources that we need for some person to actually go through everything. Or we could do our first proof of concept version with the large language models, the easy way to prove the usefulness of the business case first before we do any of this more hands-on work, and then using the lighter, more easily interpretable models for the production version. Or we could do something where we use a large language model for some steps where we don't need, for example, interpretability that much, and then use more traditional machine learning for the parts where we want to know why the model is making the choices that it is doing. So yeah, we could, in this way, reduce the resources that we need for the initial data pre-processing. We could pick and choose where we use the large language model to cut costs and kind of get the best of both worlds with this kind of an approach. But then again, we're going to get an even more complicated pipeline. Perhaps now we're going to have both work at here. Then if we use the large language model for the data labeling or annotation, then again, how we know, we come to the same issue that we had before. Is it making the decisions for the right reasons? And yeah, the computational resources. Now we don't have just the machine learning or just the large language model. We have both, and how are we going to figure that out? A lot of things to take into account. So, some things to consider when you're trying to figure this balancing act out is, of course, budget. But I don't mean that just in the money sense or the cloud costs or anything, but how much time can you spend, how much hands-on time can you spend? If it's how you're balancing that out, if you're fine with just paying the cloud costs, fine, but you don't want hands-on development costs, or the other way around, how are you going to balance that? How much upkeep and maintenance do you want to have in the long run? And of course, dataset size, because if we have thousands, tens of thousands texts, then that's what I would consider a small data set. So I would go with the traditional machine learning. But if our data set size is in the millions, then we might benefit a lot from the abilities that large language models have for this really large data sets. And then looking forward, the scale and fluctuation of the data? Is this data set that you're working with, is it this the scale that you're going to be working over time, or is it going to change, and how that's going to affect the choices that you've made? And is the data going to fluctuate? Because when we think about the traditional machine learning models, they might not be very good at generalizing to unseen, like completely new data. If everything shifts to a very different direction, if you introduce a new type of text type, for example, into the sentiment analyzer, you're going to need a new model. But the large language model might be better at generalizing even to that, even if it's so like completely new to it. And again, the interpretability, how much of it do you need and where do you need it? So maybe, for example, the named entity recognition is not something that you want to focus on having really good interpretability on what it considered a product name and why it considered that a product name. But then for the sentiment analysis, you might want to find that out. And as always, again, data governance, ethics, environmental factors. There's a lot of things here to balance out, a lot of like plates on the scale. And I would really like to give you now the equation on how you're gonna solve everything and in which case you should like pay attention to what, but there unfortunately is really no right or wrong answers here. So it's just a matter of considering all the factors, keeping in mind all these different factors and how they're gonna affect you in the long term, and weighing the pros and cons. And then, of course, when in doubt, you can use the method that I believe many of us have used. So asking ChatGPT. And here for this case, it thinks that a hybrid approach would be the best. So a pipeline of traditional machine learning models for the text categorization and named entity recognition, and a large language model for the sentiment analysis and context understanding. And yeah, that is one way of doing it. Nothing wrong with that per se, but then again, we might ponder here if we would want to flip that and want to have the interpretability for the sentiment analysis and the machine learning for the large language model for the earlier parts. But then again, that is kind of up for debate, and debate we shall. So you can get your phones out and vote on how you would solve this problem that we have. Would you use machine learning or large language model or some sort of hybrid solution? And then we're gonna see if I can actually get the results open here, hopefully. Scoot. It seems not that many of us are a fan of the going purely with the traditional machine learning, which is sad because I'm old school. That's what I would like to do. And I've actually built a system like this using the traditional methods. So I did it. Why won't you? But yeah, and then some votes for the large language model, and the hybrid seems to be the winner here. And yeah, if I were to do this again, I did it before we had this open source or GPT models that we have now. I would probably also use a hybrid because then I would save myself a lot of time, I'm sure. But yeah, interesting to see. And yeah, a few more slides and then you can all talk about amongst ourselves who chose what and why. Let's see if we can change this to the... There we go. Yeah. Some key takeaways I hope that you got out from this. If a hammer is good enough, you shouldn't waste your resources on the pile driver. So if you have a really simple task that is like won't take you a lot of time to do in the traditional way, why wouldn't you? Just in order to save on resources, and don't we all like to actually get our hands deep in the code and do it? Maybe that's a developer's point of view, but anyway. But then again, if you can cut corners with a large language model, if it's smart to do so. So you can use them for fast prototyping and getting things up and running easier. But then again, if you can get the best of both worlds, why wouldn't you? So it's often not choosing between one or the other, but balancing act of when to choose which one and how you can get the best of them both. And consider the big picture. So not just the task at hand, but how it's going to affect you going forward, the choice you make. Are you going to be fine with your choice of a large language models if the data set or the influctuation of data is getting 100 times bigger? Are you still fine with the costs, for example? Thanks. That's all from me. I hope you got some insights out of this, and if there's any questions, then I'll do my best to answer. Thanks.
Do you have questions? Well, I have a quick question. How would you go about evaluating a hybrid model like this?
It depends on what I'm using for example, the large language model part for. How important is it to me that the accuracy of it, how important it is to me? Because there might be tasks where I'm fine with, for example, the name entity recognition. I might be fine if I miss some names here and there. So I don't have to maybe evaluate it at all. And then of course you can also do like you would with a typical machine learning model. So do a train and test set, not just the test set basically, not doing the train set, but testing how good it does with something where you know the right answers for.
Do you do some output checking if you're using an LLM, even if you're asking it for a clear answer, yes or no, or any of that sort? Do you check the output?
Yeah. Because then again, sometimes even if you ask very nicely to output, for example, just the JSON, it might not be that. So yeah, having kind of like fallbacks for that kind of things, where sometimes there's something that you didn't really think of or something gets added. That is also one thing that you have to take in mind, but that often can be very easily done with just like good old software development, like checking that the
re-ask.
all that, yeah. Same but better, please.
So how about because there's not just LLMs nowadays, there's SLMs or even MLMs. How would you kind of, when you think about the LLM solutions, do you already include into that the idea of using the right kind of LLM, the right size LLM?
Yeah. Like I said, trying to for this one focus more on the concept of large language models, but then of course you don't need to use GPT or ChatGPT basically, or the GPT-4 for everything. There are things you want to do with large language models where it's perfectly fine to use a smaller model, and especially now when you can fine-tune those models to fit the task at hand even better, then that's often a very, very good thing to do. Yeah. So yeah, here I was focusing more on the concept or idea, but that might be, I think, a talk another 30 minutes in and of itself on how to choose the right size large language model for whatever you're going to do. Yeah, thanks. If that's it, are we going to have a small break or?
Yeah, let's have a small break.
Hey guys, I'm Vitali. Today I'm here to present you a video game that I'm making with my partner. But first, I'm not really a presentation guy, so I'm more of a developer. So excuse me if I fumble as we go. I put this presentation in a few different steps. It will start just from the basics, like this is like the game. Then it will ramp up into some wild stuff, because after all, we're in AI business and there's a lot of different things. But let's begin. So first and foremost, this is like really a computer game that you can buy or actually download and wishlist on Steam. It's currently in development. And the premise here is that this is an RTS game that is set in cyber realm. Basically, you can see there as a computer, and this is kind of like representation of the internet, what it could be. There's like different memes. And the hook of the game is that it supports any input mechanism. It can be a mouse, it can be AI. Well, AI in that sense is that it can be, for example, state machine, that, for example, you just write code. Or it can be like something where you can create your own data sets or own algorithms and then, train models that will compete. Because the second part of the game is that it's algorithmic esports. Basically, you have like a multiplayer where different programmers or players in different mixed modes compete against each other. So, for example, somebody who doesn't know how to program might be a RTS player and tries to micro. Maybe he played a lot of League of Legends or StarCraft. And then maybe there's some dude who's programmer. Maybe he's using JavaScript. And then he writes the code. And the premise here is that it's like a round-based red versus blue. You can think of this really like a Counter-Strike, a little bit from top down, but instead of the people, there's robots fighting against each other. But the second component of multiplayer is that, for example, here, I'm actually been on the stream explaining this as well. This was a live stream on the Asmongold's channel. Sadly, the person who was supposed to make presentation, my second partner, who I will talk at the end of the presentation, couldn't enter because his flight was delayed. So I had to do some cosplay and wear this cyber ops guy robe and then explain on the chat for like, 100,000 people, like, hey, you can actually program. And this is like Asmongold, and this is like Olivi, who is like has connections to the esports in League of Legends. And later we're going to be having this kind of segue where we're going to be having this kind of streams where we teach Asmongold to learn programming on stream. So that could be funny if anybody knows who he is. But yes, in regards to the multiplayer, the idea here is that we make code for work. Sometimes we don't want to make code when we go back home. So there's this incentive is that we have regional and local partners who can, for example, use this game as a headhunting platform to seek different programmers, regardless, like maybe they do JavaScript, C# or whatever. We just give them, access to our database. And they can, for example, fund these tournaments that have like prize pools, where, for example, people that compete in these tournaments can win this money. Because in traditional esports, for example, it's very hard to get to the level where you can get payouts. So here, our approach is that the tournaments and multiplayer matches are kind of like events. You register to them, and then the system, which is fully automated, regardless of the region, schedules you matches that you have to enter. If you don't enter them, your ranking will go down. But if you participate in them and win, you can win like prizes, money, and then like drive your career up. And here we have like regions, and then like where it's online, and then what kind of input method you have. And the beauty is that the code can be anything, and the execution method can be like, it can be pre-compiled, it can be real time. You can have like USB stick. If it's, for example, physical event, you come to the physical event and say, yeah, I'm competing, here's USB stick. And then, you compete. Now, let's move a little bit into AI part, is that because it's also kind of interesting, is that there's a lot of talks about large language models, but here we're like, this is like the product or side product of what we're doing, because games are very good at simulations, and simulations can produce different data sets. So here we're producing different data sets, and we're kind of trying to replicate, well, the segue here is that for the military uses or border security, because for example, in Ukraine there was a lot of drones, right? So we're kind of future-proofing and experimenting, like can be games, for example, used for defensive purposes, where we generate data sets and then they can be used. But of course, games, they're like games. For example, like if you're playing just, for example, Mario, the data set maybe that you get is really not useful at all for the military purposes or defensive purpose. So for example, what we're experimenting here is Markov decision processes here, really data set generation. It's still currently in work in progress, but the idea here is that we have different levels where we're trying to kind of replicate real world scenarios, what for example could be. Like for example, the easiest one is seek and destroy. Like you see something and then you try to destroy. Then you have logistics, for example, because machines, they might run out of ammo. So you need some kind of supply line. And that's, for example, what the game will try to simulate on level 2. Then environment, for example, swamps, like how difficult it is to navigate. And then finally, is the fog of war, is that we don't know where the enemy is. Now, Markov decision process is really about like now, we don't really know what previously was available. So here the premise is like we're experimenting. And the way we can do it is that because our tournament system is generating these replay files where we can fine-tune different rewards and then experiment with the people we're working with. And because, well, I said military, there's a lot of like secrecy, so the whole platform can be replicated in intranet for some certain organizations that they can use without anyone knowing, and then train in their own organizations. And it's kind of diagram, it's maybe not pitch perfect, but the idea here is that you have game client that you download on Steam, or maybe it's API, and then you connect to the website. Here we have, for example, Cloudflare and load balancing, and then we have a different CLI, command line instances running different machines that have these instances. All battles happen, in the cloud, but the code is executed on your machine. You're just interacting with API that we provide you. And then here, for example, after the battle is completed, we have our backend that crunches data sets for use case. And then, of course, after the tournament system, for example, if you win tournament, you won maybe 1K, then you can use, for example, payout system, bank account or Stripe or whatever. And lastly, this is our team. We're like 2 guys. Marcus Howard, he's business developer. He's located in the United States, and we're mostly focused currently in the United States, Texas, universities, and military there. Then I'm a Finnish guy. My name is actually Ukrainian. The funny story is that I was living in Finland all my time, but I was born in Ukraine, and then when the war began in Ukraine, the game turned a little bit well, what can I do to help? And I'm like, well, no matter the cost, how about I will try to create this kind of data set that if some, good guys will have it, they will be able to prevent future local conflicts. Because I kind of think like, we have these car factories where we have like different Tesla cars. But what will happen if, for example, we have here spot robots there, like the switch, Sure, we can like, use different vision models, but this is like part of the bigger solution. It's more about tactical level. Because, for example, if you have like this small machine that can decide in split second what to do, but then commander, somewhere in the battlefield or command center, it's a little bit harder for him to decide. Like the machines in synchronous manner can decide what to do. They know terrain, like, okay, there's swamp, we have to fall back, So there's a lot of possibility, and that's what we're exploring. But it will begin with the students, educating, because AI is going to be a big part of the future. And we're just, small cog of that. And here there's a website, and then you can wishlist and download the demo and try the product that we're currently making. The multiplayer part is still a little bit in development, and the game has been in development for about 2.5 years. It's kind of difficult challenge because you have to make a good game so that anyone who likes RTS games, for example, could play. But then you also have this backend that does something that the regular player doesn't really maybe know or will not care. So, and then because you have like different input methods where you have to also, cybersecurity, like, oh, we have to be careful that, they don't execute code on user machines, for example. So it's very lengthy process. But yeah, I think I said what I wanted to say. So if, for example, in future you want to compete, well, that's the game. Thank you. And if you have questions, you can ask them. Sure.
What is it that you actually like? You seem to have a lot of things going on.
Yeah.
You have the game.
Yeah.
Then you have the backend.
Yeah.
Then you have the data collecting part. Is your own game engine?
The game is made in Unity, and in the project there's like a few different target audiences. We currently have covered gamers, on Steam. We're collecting wish lists, and we're doing great there. And then we have dataset folks, and then people who want to learn programming. Yeah. Any more questions? All right.
I might have more.
Okay. Go on.
It's just thinking about things to ask. Do you target a specific kind of data set if you're collecting data from the game?
For example, in the United States military, they have different. So they have groups in accelerators, scientists, and they're trying to solve different problems. And we have like this specific problem that we're kind of like trying to participate in,
But you can't talk about it.
Yeah, because I can't. Would need to. Yeah. All right.
Super interesting.
All right. Yeah, sure.
About Markov chains, so what kind of other technology regarding AI?
Excuse me, can you say again?
You were talking about Markov chains.
Yeah.
So what kind of other, or do you have some other?
Well, yeah, so we're like making product, right? And we're not really AI scientists. We're more making this product and then generating data sets that they could use. And for example, this is like the best use case because, there's, for example, because, in war, for example, air superiority is very important. If you don't have air superiority or satellites, you don't know where the enemy is. So you need to have this kind of data set or information so that it can decide like on the current events. Yeah. Yeah. All right. Well, I suppose, hey.
Thank you so much for coming today. So the topic of the presentation might be the hottest topic at the moment, which is the generative AI in business. I'm really, really interested in this topic lately. And let me start with first introducing myself before getting into the details, my name is Nusaiba Kougali. I have a bachelor degree in electrical and electronics engineering from UAE and a master degree in biomedical engineering from UK. I worked, most of my career were in research, and also I worked some time as a robotic engineer in Malaysia. And then I went back again for research in data analytics and signal processing in the University of Turku. My expertise have been moving from robotics to AI to data analysis, medical devices, and now I'm back again to the AI. And I think most of these fields are connected anyway. I'm now really interested in this topic and open for opportunities now. I worked in research, but now I want to see the business perspective of these technologies. So in today's presentation, I want to discuss or examine the current adoption, challenges, and potential of generative AI in general and also within the Finnish market. First of all, I would discuss the status of generative AI, how to implement generative AI in business, the adoption, and also in Finland, how the status is, and then the most important part is how to actually implement the generative AI into your business or enterprise, and leveraging the generative AI in business, and of course the challenges and what do we expect in the future. This presentation, the main target is to create a clear roadmap for businesses to navigate and using the generative AI, integrating generative AI into the business context. So first, like generative AI is not just a technology, but it's more transformative transformative side of AI and changing and automating the tasks and generating content. A new content, and in the last 3 years, I mean, everyone was talking about the generative AI and how it changed businesses, but I wanted to understand more how this rapid change is affecting actually our life. I worked a lot with the machine learning and the conventional ways of machine learning, the deep learning, and also building just algorithms or models from pre-trained data or labeled data to get an output or a decision at the end in robotics and also in the medical field. But what we are seeing here now is totally different and interesting. And I noted that in Finland, both individuals and businesses, they are actually starting to embrace this technology and into their business. And in the last few months, I have been not interviewing, but kind of discussing with people who are in the business. What are their plans for the future? How do they think about AI in their business? How they're gonna improve their business using this technology? So according to this McKinsey global report, it's clear that there's a lot of plans about adopting the generative AI. 33% already of the companies, they're already adopting AI, while 25% are now in the process of integrating AI. There have been many estimates. I tried to look at all the estimates just to see what we are heading to. No one knows. It's a black box, definitely, but with the increase of the key players that we have right now and the change of the technology from the model training and also the LLMs and how they kind of changed the way we work with AI and the specialized softwares and the multimodal AI and computing, all of these areas are growing now, and it's clear that this will definitely boost the economy. No one has any doubt about this, but people are still scared and still wondering about how this technology will affect the businesses. So applying generative AI into businesses, of course, it has many impacts. There are many expected positive changes. Of course, it's expected that it will change the productivity and boost the productivity and profitability in the business, and also expand the R&D. There will be more customized experiences for users and more innovations and better decision making. I noted that there is a lot of adoption in this field, of course, in the marketing specifically, but when I looked at the data, I realized that there are many fields and sectors that will be actually affected by this technology, especially the banking and the insurance. They came first. Of course, I'm interested in understanding and now already starting to research, doing research with the OBO Academy about this topic. And for the energy market, because I've been lately very interested in this, and I've been kind of active contacting people in this market. And about a month and a half ago, I had an interview with an energy company, the Fortum. And at the end of the interview, I asked them a very interesting question about what are their plans, if they're really planning to implement AI in their work, because it's more about data analysis for the energy market and prices. So this will definitely change the whole game, and it might save lots of money. The answer came that they are really interested in this context. They want to understand how this can change the work, but because it's the bigger companies, I noted that they are a bit hesitating about applying this technology, but they are open to it. So this really kind of encouraged me to also approach more people. And just 3 days ago, also, I was talking with one manager in the SSAB who are doing really great work in the building a new type of steel, so manufacturing. I didn't ask about AI; it just came with the conversation, and the manager said that there was already a budget already now made for applying specifically the generative AI into the business, and I'm curious to see how this will be, of course, applied. So, I mean, in the whole world and also in Finland, it's just growing much faster than I expect. We all know that's growing. We all know that it's affecting the businesses, but it's more than I really expected. So, in Finland, the statistics came late in this year, and a report published by Sulita, they kind of researched about the top 500 companies or biggest companies in Finland, and they made some interviews and tried to collect data to understand what is the perspective of the Finnish market towards the generative AI. It turns out that only 70% of the top companies are actually using AI. 1% of these, they're actually advanced in this technology already, and almost half of more than half of the companies, they're already kind of preparing themselves for pilot studies about this topic. But interestingly, the leaders, although they're very positive, but only a few of them, they anticipate actually the immediate impact, of course, because they can't risk it and just invest in something that they don't know about and how they will be able to implement it in their work. And there's a clear gap here between the anticipations or what they believe and also the real actions. Though the beliefs are there and everyone is positive about it, but at the same time, I mean, the actions are going a bit slow in applying it to the real cases. So in another report, Google report for the economic opportunity of AI in Finland, an interesting fact came that to maximize the benefits of the AI across society, Finland needs to leverage its strong performance in AI research by promoting innovation, investment, and AI talent. So there's still, of course, a lot of work, although Finland stands really high for applying the technology as compared to many countries. But there's still, I mean, generative AI is expected to boost the Finnish economy by 20 to 25 billion euros already. So, but the good thing here that although we are all afraid about the fact that we might lose our jobs for AI, but the good thing that the jobs that are related to the AI, it's expected that there will be more opportunities in this. So people need to really build skills in this area, because there are going to be a lot of work opportunities in this already. So now let's move to the most important point, or the main point that I want to discuss, is how to actually implement this the generative AI in the enterprise. What do the companies need to do in order to successfully implement it. For individuals, the choice is easy. I mean, if you are interested in using generative AI, for example, if you want to use the ChatGPT, you can just use it or subscribe and use it for your own purpose. But if you are building a business, the question is it's not just about starting or implementing something that's ready. You need to ask many questions and do many plans before implementing the solutions. And the first thing is the generative AI, is it the solution? Because I noted that many people, they're just so positive about it in a way that I will just apply that. I'm thinking about applying that, but do you really need it? Because it's going to, of course, cost money, and you need to make sure that it's really the solution for your problem. Also, what are you putting into the production? What is it that you actually made? Because the answer of this question will open the door for all of the other aspects that will come after that. More importantly, the budget. How much money do you have? And I think in the first presentation there was a very interesting points about this and about the budget. That it's all about. It's not just that you just bring a solution that you think it's innovative, but it's about understanding your problem. Do you really need this? You don't want to consume many resources that are not needed, of course. Also, how to scale the generative AI to achieve actually your goals, and how can we actually implement the model to serve the purpose of the business idea. And of course, the most important thing is are there any possible partners to help us in the implementation? Because that's the key. I mean, if the bigger the model, the more complex it is. So there is, of course, a need for partners and vendors to be able to apply the technology. So the LLMs are already, of course, expensive and also complex. Sometimes depending on the problem. So there is a need for, of course, pre-planning, as I mentioned, from an early stage. So this pre-planning needs to involve understanding the use case, the model size, the pre-training, the LLMs inferencing, the tuning, the hosting, and the deployment. So if I take each one of these one by one, just to break it down and to understand how this can affect actually the choices, for the use case, different use cases require different methods, and also they give different kind of output. So, and for some companies, they already have more than one case at the same time. So they can't just apply the same solution for all the use cases. That's something that needs to be researched at the beginning. Also, there is a need for having a partner or a vendor that will actually evaluate and allow you to actually run some pilot studies and try different models, play with the parameters until you find the best solution that will give you the best performance with the lowest cost and the fastest speed, of course. So that's the key, is just to be able to have this kind of flexibility at first. But it has been already, like I tried to look at some use cases already. I noted that for every use case, there's a different kind of plans or implementation. And this is what many businesses kind of miss. It's not that one solution can be applied, of course, to the same problem. And then the model size. Of course, the larger the model, the more complicated the model, and the more parameters are needed. And these parameters are usually in billions numbers. So it's important to actually understand or decide what is the model size that you want to build. Because based on this, you can actually navigate through the availability of your resources, your budget, your plans, how you can balance between the model performance and size, which is a very, very important point, that everything will be based on this in the future. The pre-training, of course, it's a foundation of the model. To build the model from scratch, you need to decide first, are you going to use a pre-trained model already and add it to your business, which of course this will be great if you can find that. It will save a lot of money. You don't need to do the pre-training from zero or from scratch. So that's something very important. Or are you planning to just use LLMs or mix between the LLMs and the conventional machine learning techniques, as mentioned in the first presentation. This requires, of course, lots of computing and time and effort if you want to start from scratch. And of course, in this case, of course, you need to evaluate the investment and the pre-training to justify actually your outcomes. So then the inferencing, and which is more about generating the responses using the large language models. And this is a very important here. If you want to save money, you need to really work on this, because here you just adapt the pre-trained models into the new tasks. So it involves understanding the prompt before, like, and how the model is responding actually to your questions. How can you get the best kind of questions or the best inputs to the system so that you get the best output at the end. The cost of this, of course, it depends on the complexity of the system and the completion time. And I noted that there is now lots of work with this prompt engineering. That's a new term or a new field of engineering that sounds very interesting for me. And I think it's very important, and I'm expecting that there will be many jobs also in this area. The tuning, which is of course a very important thing, and to adjust the parameters, of course, of the pre-trained or the trained model. And here a choice needs to be made if you are using which kind of tuning. Are you just going to use fine tuning? If you are going to change the whole structure and the whole parameters, or your problem can be solved by just selecting specific data and just do some changes into that one. That's, of course, will definitely save a lot of money if you are just doing the structural changes to only part of the model. And or also, if you have already your own data, you can also add that into the model, and of course that will really help you to kind of solve many problems that can come from just using pre-trained model. The cost of the label data acquisition also is important. There's a need to carefully tune the model to ensure that it will actually serve your need. That's the main thing that you always need to put in your mind. What do I need to achieve? And you always need to put the accuracy, of course, first. You want to get a system that actually works. So you need to play a lot, of course, with the tuning and think about many things here. And of course, having the partner or the vendor here will really help to plan this further. Now, after you have the model ready, it's time to maintain actually this model and bring it together. So, of course, you can use API inferencing. I believe there are many companies are doing this API services, including where we are here, of course. And so different use cases may require different ways for connecting the model. But it's important to consider the scalability, the cost, and also the data control in this context. And now the deployment, or where are you actually planning to host this system? There are many choices, of course, but the most common ones are using the SaaS, or of course on-premise if you can afford that. The SaaS, of course, offers predictable cost. You have shared GPUs. You don't need to pay for the GPU here. But if you really require to purchase GPUs for the data here, you need to, of course, consider many things before getting it to just put your data into GPUs. And of course, the partners here also they can meet the deployment needs if you need more advice about this. For leveraging generative AI, I mean, the fields now are really growing, and the most key thing for big businesses is to be able to hire the right skills or improve the already existing skills that you already have in your business. But first, you need to, of course, do some feasibility studies to understand what is actually, if the solution is actually feasible, prioritize your tasks and also the use cases. If you have more than use case, you need to prioritize each use case based on your needs. Talent acquisition, as I said, hiring the right people and getting the right help, finding the right partners. Risk, there are always risks and there are always challenges in building this, and I will discuss this in the next slide, but that's something very important to consider, and also the alignments to bring everything together in order to get your target. So the skills are, there are different kinds of skills here, and they're just not just about the people who are having experience with the AI or the data, but it's more than this. I mean, I noted there are even lots of work now on the understanding these problems into with the ethical, from the ethical sides, and also from the cognitive, also having cognitive skills to serve these purposes. So there are many challenges expected, but the main challenge is, I think the most common challenge is the data security and of course the privacy. That's really a big problem that many companies will already experience. And the more sensitive the data is, the more complex dealing with this problem. And I was working with medical data, and I can't emphasize how working with this sensitive data is really, really difficult to get ethical approvals and to make sure that you have met all the security and privacy conditions. Of course, you need to earn your customer trust in this. So that's also an issue here, that you need to be able to, after you build your model and you have your product, how would you actually make sure that your customer is actually satisfied and trusting that you are saving their data. And of course, the ethical considerations are there, the biases in the AI output, and also the hallucination of the network. This is a very common problem. We can't just trust the outputs. Even when we are using ChatGPT, the results is not always accurate. Doesn't mean that it's always true. Sometimes you just feel that, what is this result? What are you saying here? So that's also a common thing. And the operational integration, of course, this is also expected. That there will be many issues in this in the system, and the workflows can be very complex depending on the complexity of the business problem. Also the lack of skills and resources, although now people are getting more into this and they are more knowledgeable. There are many skills already, many experts, but there's still need for building more work in this to make people to add more professionals in this field. So maybe that's a funny news that came about 3 days ago. Maybe many of you already heard about it, the OpenAI, how it actually collaborates now with the Apple. And in just 3 days, I was shocked to see how people got scared. All the iPhone users, they're a bit concerned about this problem, and that shows that now the society that we are in now, people are educated, people understand what is AI, understand how it can affect their life and how it affect their privacy. They're more aware, not like before. I still remember back in 2016 when I started to work with AI in robotics, not many people, only the experts, they discuss about this, but when you just talk to your mother or you talk to your friends who are not in this field, they just, okay, AI, okay, it sounds cool, but no one understand what this AI is. But now it's not like that. So people are really, you need to understand your audience, and you need to really understand how things are going in order to keep track and build a successful career or business. So what is the next step, or what's the future requires in order to have a successful implementation for generative AI in businesses? I think investing in the technology and talent is very important here. Of course, all the business leaders, they're afraid now, they're now in a stage that we need this, we need to build this, but at the same time, but we don't have the talents. But what can we do? So I think there is a need to invest, of course, in this. If you want to build something successful in the future, you need to invest in it. You need to invest in the technology and also educate your staff, the already existing staff about it, and also try to find also talents that would serve your need. Of course, outsourcing the tasks from the beginning and trying to make a clear plan before just going into the implementation. Spend time in research, spend time in studying your problem, try different things. And also here comes the role of the research, because I work with research myself, and I believe that it's very important now to have this kind of collaboration between research and also the industry. And this is what I'm interested in lately, is to have this kind of, to be kind of in the middle between this, because I already have research experiences and I have technical experiences. I want to be able to bring my experiences into the business, and I believe that many people should do this already, to actually collaborate to the future, and also having strategic plans or clear plans about what is your business problem and what you want to achieve at the end. I think all of these things are important to consider. And for this question, like what should we do next, I think everyone will give a different answer based on their understanding, based on their needs, based on their plans. So it's really an open kind of question what we need to do next. So thank you for listening to this presentation. And I think because this presentation is more informative and trying to kind of open the eye into what we actually need to do. So I expect more of a discussion rather than questions. Really interested to see how people are approaching this problem. And yeah, let's hear if you have any things we want to discuss together, or any fears or whatever it is. Thank you. Are you scared? You look scared.
I'm not scared.
Anyone afraid about losing their jobs because you work hard on something and then at the end, okay, you work as a, I don't know, AI engineer or AI developer, and then at the end, you're not needed. It's expected that now, even the data, I read a very scary news about the data analysis job, that it will disappear in the future. And I'm already now trying to approach, because I already worked with this. So I'm now, okay, trying to see many opportunities in the data analysis, but I always think, okay, what if I started working on this and then in 2-3 years, you're not needed because AI is gonna do it. So.
It will be more like weekend assistants that are digitals, something like that. So that you're still doing your stuff, but at the same time use like a smarter tool that will think a little bit by itself. I see it like this in Twitter, so maybe it's that dream. But I don't think we're going to lose a job. We're just going to have a different character.
Yeah. I mean, I myself am positive about this, although many people are scared. But I believe that, of course, the human part will always be needed at the end. Maybe in the very far future, things will change, but at least for the coming decades, it's expected that the idea of the AI is to actually help human to save time and also to increase the productivity. So having this kind of assistance will definitely be helpful for many people. And I think the smart thing to do now is to kind of research about what is expected. No one knows what's going to come in the future, but just research about what's expected, so you know, okay, this is the future, so I'm going to build skills in this area so that I will have job in the future. So I think that's the smartest way yeah.
As a person who is a network and security engineer and at the same time LLM researcher, I can assure everyone that ChatGPT and other LLMs, they're super bad with network debugging, network issues debugging, and the cybersecurity. So you're safe, but it was actually a topic for debate, like if the LLMs and other things, they're gonna take the work from us. But my recent research, I actually did manage to make ChatGPT to generate the machine learning code for me, which was serving the security feature of classifying the network packets analysis to classify if it's malware or legit. So to some extent, yes, it can take jobs, because if we consider a company which consists of 1 or 2 people, they actually can now cover a wide area of tasks. Basically, without prior knowledge of data science, they can generate the code and actually operate it. But at the same time, the LLMs, the currently large language models, they are not well enough to take it fully. So it's like kind of 50-50 thing, that it might take it, but it also might fail.
Yeah, of course, still lots of work needed to.
And it depends on the industry.
Yeah.
Like, I highly doubt
Exactly.
that we in near future will manage to have a car mechanics or something like that. We'll still always need other professions, like high-end professions. They might be overtaken by AI in the future, maybe 5, 10, 20 years, but generally people are safe.
Yeah, that's how I also look at it. I'm not very worried. At least for my lifetime, I don't know what will happen in 50, 60 years. But yes, that's a good point. And also it depends on the industry. And that's what I also realize while I'm doing this kind of research, because I just started with this and I want to continue with this more and more, to dig inside this thing, because it's growing, and I'm just curious to see how it's going to be implemented with all of these kind of estimations. We know that's going to grow and it's going to boost the economy and going to change many things. It might even create more jobs instead of decreasing the jobs, but like understanding how this will because what I feel is that people are just so surprised about this and just want to implement it. So what I want to understand and work in is to help in understanding how we are going to implement it to serve us. So that's the thing. It's not just about. It's not just something that you build the model and just as we used to do. I used to work with models and algorithms and just to get the accuracy as maximum as I could, which was very boring sometimes. But now it's different. Now it's not just about the conventional machine learning techniques. So I think, yeah.
In game industry, it's quite interesting is that people who can't make art can now produce it, which like hides that people who actually can make the art. And then they take some opportunities from them.
Yeah.
And then these platform holders, they don't maybe really understand this technology yet, but when they do this hard pass. You have to prove us that you made this. Like, you have to show us PDF layers, for example, that yes.
Yes, and also in the studies with the students, because you can use the ChatGPT, so now all the instructors and teachers they have to test every homework to make sure that the student didn't just use ChatGPT to copy it.
And for example, if indie developer, for example, makes a game, he wants to buy assets. Now, like, is this asset made by human or, AI?
Yeah.
Which is like also takes opportunities from, real talent. And if you don't have, some platform to actually, elevate your voice or, marketing that, hey, I actually do art. It's bad.
Yeah, it's bad.
This actually all boils down to trust.
Yeah.
So it's trust all the way down. Do you trust the code that the LLMs generate? Do you trust the commands? So for a human, you have this implicit trust if they haven't made a mistake. But anyone who has used LLMs know that they make mistakes.
Exactly.
So the level of trust is always lower. And that's why I think we are a very long way for losing our jobs because of the trust issue.
That's actually interesting because, say, large language models, the data is probably stolen to some degree.
Yeah.
And the government use that data, elements that use that, probably not. So they will have to produce it somehow. Yeah, long way.
Definitely.
Yes.
That kind of question, I started thinking of course, there's a lot of machine learning solutions that are implemented in the industry, in processes, generating tangible results, and then those ones that are acted on for LLMs, like real business decisions that are then acted on by the company. And of course, there's a risk to it. If the decision is wrong, probably they will lose money.
Yes.
You know of any, because the only one I know of is Klarna chat engine, or this chatbot. It's completely automated by LLMs, and they actually act on it, and they kind of take responsibility of it answering the right way. So do you know of any other places? Like otherwise LLM is for me only it's kind of a novel writer. It kind of speaks out nicely, yes. Generates code, yes. But there's always a human that will check through if it is acted on.
Yeah, of course, the human perception about this can vary from a person to a person, but unfortunately, the LLMs, of course, can do many mistakes, and that's what many people don't understand. They just trust what the AI says. So I think there should be a lot of work in this privacy issue, and also the security issue of the data, and also to boost the confidence for the user in order to trust the system. That means we need to build more trusted systems, of course. So I think, yeah.
I was thinking of like automating the process. If the input is natural language, then machine learning can most likely kind of tolerate it because it's not numbers. And then if it's text, then of course Gen AI could generate a proposal for an output. But then comes this trust issue as was discussed then.
Yeah.
Who will take the blame if it goes wrong?
Yeah.
Tesla not
Okay, yeah.
private
The self-driving cars. Yeah, this is, sorry, I misunderstood your question at the first time. Yes, like this self-driving car is a really excellent example for this problem. I have kind of also dig into this for some time, and still, now people are still discussing who will be blamed, of course, if something happened. But yeah, you never know. But the idea is that of course that's why there's now this kind of profession for AI lawyer, for example, to be able to govern these problems if something happened in the self-driving car or for any other problem. So there is of course need to work a lot on this. This is an open problem. I don't see it solved, although there's a lot of research in this. But people always have trust with these automated decisions. Now I think many insurances and also social kind of systems, they're using this. For example, the immigration service, they're using it. There are many kind of platforms that are using this kind of automated decision, and people are wondering, okay, what will happen to these systems? Like all the services, they are planned to be automated in the future. So yeah, people are just curious about it, and I don't know if we should trust this automated system now or should work on it more. I believe there should be more work on the systems.
People are going to learn how to game them as they do every system.
Yeah.
So
Actually, two comments I wanted to add, if we have time, of course. The first one is actually the AI is not obviously mistaken regarding certain issues. For example, from my own experience, when I was generating the code for my software application through the AI, it was machine learning code. And what AI did is that the code was overfitting my data. Because AI skipped the step of cross-validation. And when I asked, like, here the data is overfitted, most probably you've never implemented cross-validation. And AI answered, like, yes, true, that's the issue because cross-validation was never implemented, but you never asked.
Yeah.
So, like, it was kind of this type of a reply, like, why you never asked me to implement cross-validation? Like, I know that the code needs cross-validation, but you never asked me to implement it, dude. So, yeah, and that's why and that's also touching the topic of if AI can take our jobs. Like, you still need to know the theory to be able to correctly build your prompt for this generative AI to get the proper output. And the comment regarding your question, basically with legislation and AI, it's a bit complicated topic since, for example, Italy banned the ChatGPT in March for 12 days because the Italian authorities, they thought that ChatGPT does not violate the GDPR policies. However, they did not take into the account that this OpenAI ChatGPT is different thing in its nature. So you cannot apply the technologically neutral regulation policies to it. Therefore, now they're actually working, and not only to the other governmental entities as well, working on a set of laws and rules how you can actually govern this AI with like technological point of view on this. Therefore, yes, they are actually working on it now, but there are no solid documents on like if the car crash with AI-driven car crashes, who is responsible?
Yeah.
So it's like it will take some time before they come up with this set of rules.
But what is the role of the prompt engineering in this? Because I find this very interesting.
Was first comment.
But like, what do you expect? Like the prompt, because if the first part of your discussion was about the prompt, what you actually ask the system, and then So I always wonder what is the role here of the person who's responsible for the prompt engineering here, like.
Oh, okay. I see. Basically, it's about the knowledge, the background knowledge. The better, as it works, at least according to my personal experience, the better you build the prompt, the better will be the result. For example, things like act as a data scientist with 10 years of experience can already solve your problem of ChatGPT doing the cross-validation. Because once it's actually proven that once you set the role, once you tell the things like certain things or certain keywords, it actually boosts the performance. I think it was even mentioned in the first presentation that let's analyze it step by step. Let's think of all of it like step by step, like things like that already improve the performance of the machine learning models. And for a while, it was actually considered that prompt engineering will be the job of the future.
Yeah, that's what I also thought.
But recently, another LLM was developed that can actually build prompts you need for any type of the tasks. So you never know how it's gonna work. But basically, yes, the prompt is one of the most important things. So if the person who is building the prompt, he knows what he's talking about, the probability that the output will be successful is way higher. Because if you, for example, tell ChatGPT, like, build me a model which will predict the future, and when you actually step by step explain what do you need, for example, I need based on this and this and these parameters for model to predict this and this and these possible futures. It will be you will get two different outputs. While the first output will be something vague, like you cannot really understand and you cannot really use it, and while the second prompt from what you actually generate, because you know what you're talking about, will be totally different and more effective.
Yeah.
And the same with cybersecurity. Like while I was doing the research in cybersecurity, while you ask like hack me this website, you will get almost nothing. But when you actually clarify your request more, like hack me this website using this vulnerability, using over this port, using this IP, it will be way better, and you will actually get desired result.
Yeah.
So the background proficiency of the person who operates this LLM, the operator, it actually matters a lot.
Yeah, of course. Good point too.
I have a couple of comments. Oh, one slide back. So I believe you mentioned yourself. What do we do next? You are the ones who do. There was a self-driving cars mentioned, I believe it was only end of last year, that the Vienna Convention recognized that not every car needs to have a driver, but it can be remote control, or there can be some automation that drives. So it is coming slowly, but definitely. On the other hand, a huge change here is with the UI level, that even the illiterate people are able to act with digital world, and also the retired. Yeah. I'm not sure, but I've been helping my retired parents ages to do things. So you can just think that in the future, they are able to tell, I would need to make the meeting minutes for the retired people society, please. And then the machine starts doing that. And that's a huge opportunity.
be great.
Yeah,
Yeah, it's a great tool for accessibility. Sure.
it's a great application at the moment, like a very interesting one actually.
Should we end the formal part of conversation?
Yeah, we keep talking about this, it will be no end. We talked about it till tomorrow. Yeah, we'll never know the future, but yeah, I think we should just be optimistic about it. Yeah.
Let's turn off the AI. To be safe.
Thank you, Nosy.
Yeah, okay.